Hi viewers, this is Sri Ramlu. So today's topic is impedance to the wave motion. So what is impedance? So it's a general formula is there, and according to this syllabus, one more formula is there. So which is right, which is we have to write in the examination as you wish. You can write either both or any one. But uh, actually you must write this one. If you do not write this one, but you must write. Why? Because with this formula only we can derive here the impedance formula. Okay, what is C? The inherent property of the medium by which it opposes the wave propagation is known as impedance. So its simple meaning is that is a property of medium which oppose motion of the wave. Suppose the wave is traveling in this direction. Something can decrease its motion, something can oppose its motion. That something of the medium is simply we have to say it is impedance. Now let us consider a string having linear density mu and tension T. An external force F is applied at one end of the string so that a transverse wave propagate in it in positive direction, positive x direction. So what we have to say here something. So here let string is having the linear density mu and its tension. When it get a tension, when it is suspended to some weight, or when it is fixed between the two support, rigid support. So here what we are doing, we are applying external force F. Oh, okay, on any one end. So one end is fixed here and other end we are applying this end. Okay, so end of the string so that transfer waves propagate in x in it in positive x direction. So see here it is a fixed here, and what I'm doing, it is initially it is like this, and along which direction, positive x axis. Now suppose just it is up to here only, let it is considered from here to here. This side is what it is rigidly supported, this side, and this side at this end what I am doing, I am holding, means I am applying a force, which force this much. Then just if I do up and down, up and down, then what happens, it starts producing a wave like this, is it? So here at this end, let the position is what at the origin, let it is origin, considered as origin. At this point what its position is x0, and see at the beginning if I apply the force like this upward direction, then when it starts wave like this. Okay, so applied force is F is in this direction and the tension is in this direction. Just resolve this point like this, then t sin theta we will get, right? So t sin theta, how it is we get, so this direction cos theta and this direction sin theta. Okay, so that is already I explained in many videos, please watch those videos. Okay, now according to this syllabus, a definition is there. The mechanical impedance is also defined as, we can say the simply impedance or mechanical impedance. Okay, the ratio of external force F to the velocity is called impedance or mechanical impedance. Here external force is simply F is equals to F naught e power of I omega t, and transverse component T, transverse mean perpendicular component, T sin theta, right? T sin theta are equal and act in opposite direction. Okay, like this as shown in figure. So Fy is equals to minus T theta, minus indicates opposite in direction, right? If you pull it upward direction, suppose if you have the wire like this, it is fixed like this. Just if you do upside direction, then tension also act in this direction, and resolving, then what we get, what we get here, two components we get. So one component is sin theta, other component is cos theta. When theta is small, sin theta is approximately equal to tan theta, right? And why it is sin theta is equal to approximately tan theta? If you substitute, see here, sin 0 value, what you get? 0. See, whatever answer you have here, you have the same answer you are getting here, isn't it? If it is sin theta, then we can write theta simply when theta is small, isn't it? It is also theta when it is small theta. In the same manner, for tan theta also we can apply. When tan 0, answer is also 0. So what we are substituting here, same answer we are getting here. So that is why for sin theta and tan theta same value we get. So here sin theta is equals to tan theta. Tan theta can indicates as slope. Slope means y component by x component, change in y component by x component, right? And see here, in the place of sin theta, so sin theta will be replaced by this, then this is the formula. And let it is a equation. So f value also substitute here, this f value here, then it is what? It is the second equation. Using the wave solution given by, so we know the wave solution of a string. So this is wave solution of a string. Y is equals to a into e power of I omega t minus kx, and differentiate it first. Differentiate it with respect to x. So it is with respect to x, and at x is equal to 0. Why it is at x is equal to 0? At the beginning, right? At the beginning x is equal to 0. So in this formula this term will 0, then we get this one. Okay, now we can easily substitute this formula in the equation 2 here. So here it is a minus, see, observe it, e power of I kx is simply minus k e power of minus kx, isn't it? Same formula is written here. We are doing differentiation with respect to x, only x coefficient will come down along with I k minus, here minus k is there, and if you multiply I value minus I k, isn't it? So minus I k comes down. Okay, substitute in this equation 2, then we get this one, minus minus gets cancelled, means it become plus e power of gets cancelled. This is the formula. From this amplitude is what? A is equals to, this is from this. And now substitute this a value in the equation 3 where it is here. Substitute there in the place of a. Okay, substituted in the place of a, and we got this formula. Okay, after getting substituting this value in the place of a, we got this one. Now once again, now differentiate it with respect to time only at what? At a same position. Position is same. At x equals 0 only. What? We have to differentiate it with respect to t. At what? X is equals to 0. Okay, t. Then t coefficient comes down, isn't it? T coefficient what? I and omega. So I omega comes down after differentiating it. So I omega, see, I omega there. Okay, already in the denominator I is there, and this I and this I gets cancelled, right? And one more thing, omega by k simply v. So in the place of that v is substituted, then the formula finally f naught v by t power of I omega t. So this is what it is, a u value, and f value already we know, f is equals to f naught e power of I omega t we know. So substitute f value and this value in the equation 1, that is what? Z is equals to this is. Okay, so substitute in the equation 1, f value is this one, and u value is just now we got this is, then f naught and e power of I omega t gets cancelled, then finally t by v will be there. So but according to formula t by v, see, so v is equals to under t by mu, v square mu is equals to just to t only, it is not question mark, it is wrong, no question mark. So then substitute in the place of t, t is equals to v square mu, v gets cancelled, v. This is impedance equation, friend. So don't forget watching this video and subscribing. Thank you.